we're going to consider two situations where we have set of raw data and the observations in the data is odd. We see what happens, and where the observation of data is even. So let's start with the odd one. So here we have the ages of 13 passengers on a bus, and these are the ages. And if you can recall the 5 main things that we're going to calculate, median is one of them. And the moment you want to work out median, you need to put your data in order, because the definition of median is the middle data of an ordered data. You cannot just pick the middle number if the data is not in order. So first is we put the data in order. So that's what we've done now. Now we can work out the median. The easy way to work out median is cross from both ends one by one until you get to the middle, because you want to know the middle number. So you can use this technique by crossing until you get to the very middle. So you can see I have 11 as our middle number, so median is now equal to 11. Now, one interesting aspect of this is that the moment you work out the median will split the data into two halves. Median will always split the data into two halves. So we have the first half, then we have the second half. Now, it's very interesting that whenever that happens, you can easily work out the median of the first half, and that will stand for your lower quartile. You can also work out the median on the second half, and that will also stand for the upper quartile. So let's see how to calculate that. So we're going to work out the median on the first half, cross from both ends until we get a middle number. Now realize that here we don't have a single middle number, but rather we have two. Whenever you have two middle numbers, all you need to do is work out the average of the two, and that will represent the median. So you're going to work out the average of 5 and 7. 5 plus 7 divided by 2, that gives us 6. So our median for the first half is 6, but this median represents the lower quartile. Don't get confused. It's median for the first half, but it represents the lower quartile. We are now going to work out the median for the second half for our upper quartile. The same principle. Also two middle numbers, so work out the average, add and divide by 2. So we know our upper quartile is 22. Now from the data you can see easily your smallest number and the biggest number. So I have my smallest and the biggest done. So my 5 main calculations that I need for the box plot is now calculated. 3, 6, 11, 22, 27. Now, like I said, we must put the data into quarters. Let's check. You can see 1, 2, 3. That's a number. 1, 2, 3. That's a number I'm using. 1, 2, 3. That's a number in that order. So this is definitely a quarter. First quarter, second quarter, which is the median, the third quarter. Let's put it on the graph then. So smallest is 3, lower quartile 6, median 11, upper quartile 22, the largest or biggest 27. Then all you need to do is that the upper quartile and the lower quartile will make a box, and you just join the lower and the maximum or the biggest number with a straight line to the box. Simple as that. So remember, the box represents the interquartile range. If you want to even work out the interquartile range, it's simply the value here, which is 27 minus 6, and that gives you your interquartile range. Second example is where we have the observation in